just want to talk about relief valves on an excavator, and I want to start off with the main relief. So as we saw on this excavator, there's two main pumps, and the two hoses coming from those main pumps feed into the back of this control valve, which is pretty centrally located in the machine, as it tends to be on an excavator. Not always, but they try and get it in the middle because it's a central distribution point for oil, so they want it to be kind of in the center of the machine. And of course we've got all our functions here. So the relief valve for this machine, and quite common on excavators, is in the center, and it's got to do the relief or maximum pressure limiting for both pumps. And generally what they do on a Caterpillar excavator is one of the pump flows will come in and sort of feed, it's not a hard and fast concept, but it'll basically feed one half of the functions. The other pump flow will come in and feed the other half of the functions. So we've got a pump for each side basically. And often on Cat machines, not this particular one, but often they'll kind of make it left and right, like the controls are left and right. They'll make whatever's controlled by the left joystick, on the left side of the control valve, and right joystick, but not this particular one. But the travels are left and right the way this is organized. But we've got our main relief in the center here. And if we're going to have one main relief that has to limit the maximum pressure for two pumps, there's going to have to be some kind of a system that gets pressure from either side to that one main relief. And that's taken care of under these two check valves. So under underneath these two plugs are two check valves, and they're called main relief check valves. Nice logical name for those. So this is out of a much larger Caterpillar excavator, a 345. So that was a 7-ton machine. This is a 45 metric ton machine, basically 5 times bigger machine, much larger, but same system. This is only actually half of the main control valve, so this would bolt up to the other half, and they sort of cast it in two monoblock sections, and then they bolt together. So on this one, we're looking at the front side, but the pump flows again from the two pumps connect here, where these flange clamps are. So that's where the two pump flows would normally connect once this valve's installed in the machine. So you got left pump, right pump, or pump 1, pump 2 coming in here. And one pump would feed, on this machine, the one pump does feed the one side of the control valve that matches the control pattern for Cat excavator. And the other pump basically flows through the connection here and feeds the other side. And then again, we got one main relief. Sort of a big main relief here, but and here we've got those main relief check valves again. So underneath these plugs, we're going to find a couple of check valves. So just getting those out. They're just what you'd expect, sort of a mushroom-shaped poppet and a light spring, and that they're not cartridge type. They just sit in there like this. And the other one is here. So they sit in there. This would be the bottom check valve. This would be the top check valve. And the way these would work, if the bottom pump's got higher pressure, the one feeding in the bottom here, it's going to push open this check valve, and it'll go up in the internal cavity to the main relief valve to be sensed at the nose of the main relief. So if it's got the higher pressure, it opens, and the pressure then pushes on the step on this check valve and locks it shut. If this pump has the higher pressure, then it opens this check valve, goes down and locks this one shut. So whichever pump has the higher pressure, so these are going to, as you're working the machine and the pressures are going higher or lower, left and right side, these two check valves are going to be busy shuttling back and forth, figuring out who's got the highest pressure and sending that to the main relief. So having thrown around the word shuttle there, you might wonder, why don't they just use a shuttle valve instead of two check valves like we saw in our load sense systems? They could build that into the valve too. Whoever's got the higher pressure moves the shuttle valve, higher pressure comes out, goes to the main relief, and some manufacturers do that. For some reason, Caterpillar's stuck with this method since the early 70s. Then if I take out this main relief, you can just see how it lives in the cavity there above the two check valves. And big main relief, because like the 307, this is a dual pressure main relief. We've got a screen there you can see on the supply end too. So if some debris tries to get into the pilot poppet, it is a pilot operated relief valve. Lots of lock nuts and adjustments here, and an oil connection on the end because like the 307, this is a dual pressure main relief. This is going to control one maximum pressure for implements, boom, stick, bucket, swing, and a higher setting for travel. So when you travel on some excavators, pilot pressure will actually go in the end cavity here and push on a slug, and that slug will move down and actually make a temporary adjustment to the pilot poppet in the main relief. So it's like the operator jumps out of the cab and cranks up the main relief setting every time they travel. So excavators aren't the only machines to use dual pressure main release, but it's pretty common on a lot of excavators, and especially in Ontario. So this one's out of a Volvo excavator, and it had a connection again where pressure could come in and boost up the relief valve setting while you're traveling. This is one off of a 307 like we've got out in the shop there. Again, dual pressure main relief, oil pressure coming to the end. It's just pilot pressure that moves a slug in there. We'll take this apart and look at it in a sec. So I mentioned in Ontario, and why specifically in Ontario? Well, because we do a lot of sewer and water main work with excavators in this area. People that buy excavators tend to buy them with long undercarriage. So if you see an L in the model name of an excavator, like a I don't know, Komatsu PC200L or a CL, sometimes after the generation they'll have an L, or sometimes you'll see LC. L stands for long undercarriage, LC for long chains or track chains. And those machines, because the tracks are longer, it makes the machine more stable for lifting sewer pipe and manhole covers, and for doing civil engineering type work. It's a very popular option. It makes the platform of the machine more stable. But when you lengthen the tracks like that and order that option to have long undercarriage, then it makes steering the machine, because excavators inherently skid steer. You move one track forward, one track reverse to counter rotate, or you pivot, turn around one track that's held in neutral. That's tough to do if the tracks are in the mud and you've got extra long undercarriage. So that's typically where we started to see dual pressure main reliefs sort of become standard fare in excavators. But often it's only put on the machine if it does have the long undercarriage. So all your travel may have the same maximum pressure as implements if you don't have the long undercarriage option. But that's come and went in different manufacturers and different versions of the machines over the years. At some excavators, they just cranked all the pressures up so it would steer, and then you got more force from your implements. But others, they want to keep you from doing damage to the bucket and boom and front linkage, so they will limit the implement maximum pressure, typically 500 psi or so less than what your travel maximum relief pressure is. So there's the main relief in the 307. There's a pilot line comes to the end of it here, and this pilot line gets pressure every time we operate the travel pedals. And that's done through a logic network in the valve, but basically if you travel left, right, forward, reverse, you'll get full pilot pressure coming in here, and there's another function of the pilot system on this excavator. And that will again move a slug and bump up the main relief setting. Now this gauge isn't normally here. I've just put it in here because this machine's being used for test purposes, so we can see that needle jump up to full pilot pressure every time we travel. There's no portional pressure. It's either 0 or it's full 595 on this machine is our pilot pressure.